Welcome dear students, and the topic for today is going to be similar triangles and some nice introductory problems. There is no end to the number of fantastic, interesting problems that can be based on this topic, but today we're just going to look at a few introductory problems. The general theme of this topic is a very powerful topic. You will probably study similarity throughout your life in maths, physics, and probably many other subjects. But what we are going to do today is just a few simple problems, and maybe we'll get into some really interesting, tough problems later on. So let me first run through the basic idea of similar triangles, which you all know. So when a triangle is blown up or shrunk, then we say that the three triangles are similar. One obvious idea about such enlargement is that the angles do not change. So the corresponding angles continue to be the same, and all the three angles will be equal. But the ratio of the sides, let's say that it increases by a factor of 2 or decreases by a factor of 2. Now this one is enlarged. So what we can say then, the way we write it is triangle A dash, B dash, C dash is similar to triangle ABC. So I'm just going to ignore writing a triangle. Now what this means is the corresponding angles are same. So we have to be very careful when we write down the fact that two triangles are similar. We've got to get their order right, just like in congruence. And once two triangles are congruent, what we're really trying to say is that other than the fact that the angles are same, the ratio of their sides is the same. So in this case we say that, let us say that this is double this, then every side will have the same ratio of 2 to the corresponding side on this side. So AB corresponds to A dash B dash corresponds to AB, B dash C dash corresponds to BC, A dash C dash corresponds to AC, and so on. So I'm going to just write it. This is what is the meaning of similarity. Now in this case, let's say the ratio is 2, then this ratio, this one generally writes it as K. So if K is greater than 1, that means it has got enlarged, and if K is less than 1, that means it has got shrunk. So this is the basic idea, and the next important thing is, how do you recognize that two triangles are similar? There are three ways, and I'll just state it here because you must have studied it in school. AA, that means two angles are equal, and therefore the two triangles will be similar. SAS and SSS. So what's the meaning of SAS? The ratio of two corresponding sides is the same, and the included angle is the same. In such a case, we can prove this, that the two triangles are similar. And the last one is SSS, which is to say that if the three sides are having the same ratio, like in this case, the way I've written it, then we can conclude that the two triangles are similar. So with this background, I'll just state one more obvious, nice, simple fact, and then we can get on with one of the interesting problems in this category. Now, the thumb rule in general when you are solving problems in geometry is that if you spot a pair of similar triangles, you made a headway, or maybe even you solved the problem. So, and generally some very tough problems are solved the moment you spot similarity. We'll give you examples. So let's get started. The first example that I would like to solve using similarity. Okay, before that, one simple fact, let's write it down. So the general nice idea is like this. that if two triangles are similar, so let's say ABC is similar to A dash, B dash, C dash, any corresponding length of this triangle to the corresponding length in this triangle will have the same ratio as the sides. So let's take an example. So let's say that this triangle has a height h, and suppose that this triangle has a height h dash, you can be sure that h dash over h will have the same ratio as k, which is the ratio of the sides. Similarly, let's say the perimeter of this triangle and the perimeter of this triangle. The perimeter of this triangle will have the same ratio to the perimeter of this triangle as k, or any other corresponding length, for example the corresponding medians, they will all have the same corresponding ratios. So these statements are very easy to prove. So maybe I'll just try to show you how one can prove that h dash over h is k. This is rather straightforward. Essentially what you've got to note is that this is 90, this is 90, and therefore these two triangles, this triangle and this triangle, are similar because this angle and this angle is same, because these two triangles are similar. This angle and this angle is same because both are 90. Now the fact that these two triangles are same, which means that h dash over h is the same as a dash c dash over ac, which is k. So this is a typical argument and it's rather simple. So let's now proceed to the most famous problems, introductory problems in this topic of similar triangles. The first problem is very classical, very interesting, and if you're seeing it for the first time, you're in for a very pleasant surprise. So I'm going to draw a triangle which is 90 degrees, but the triangle has been, the 90 degree has been drawn here, okay? So please do not be confused just because the triangle has been inverted. And now don't forget our standard notation, which is to call this side as C, this side as A, and this side as B. Now I'm going to drop a perpendicular here. Let's just call this D. Let's call this length as D, and let's call this length as E, and don't forget that this length is C. Now I'm going to write down a few formulae which will prove very easily with the help of similarity, and straight away you will see that these formula are strikingly beautiful and extremely easy to prove. So the first formula that I'm going to write here is that b square will be equal to bc. B square will be equal to d multiplied by c. Now by symmetry you can instantly guess this next formula, which is a square will be equal to CE. Now these are the two nice, one more nice formula, h. If h is the height, then h square will be equal to DE. H square is equal to DE. Now each of these three formulae we will prove very easily, but up front I want to tell you a nice interesting surprise. Just see what happens if we add these two equations. Now if you add these two equations, you will see that I'll get a square plus b square will be equal to dc plus ec, and that is equal to d plus e times c. And note picture that D plus E is C. So this is nothing but C square, and we got a proof of perhaps the most powerful and interesting theorem in elementary geometry, which is Pythagoras theorem. So here you see that similarity is giving us a proof of the Pythagoras theorem, and I think you will instantly agree that this is quite sensational. So let us now proceed and try to get these nice interesting formulae on the board, and each of these formula are going to be extremely easy, and it's just a matter of simple similarity. So let's get down to business. I'll also make some space for myself. So I'll try to keep the frame here, and let me try to prove this in the space here. So how does the proof go? This triangle onto the left hand side, this triangle 1, this triangle 2, which I shall call the daughter triangles of the mother triangle ABC. Each of the two triangles, two daughters, are going to be similar to the mother triangle. So all the three triangles are actually going to be similar to each other. So let's try to write that down neatly. Now let's take our own sweet time. First, let us try to see why they are similar. You can see that this angle is 90, this angle is also 90. Let's say that this angle is alpha. Then this angle, because angle C is 90 minus alpha. And if this is 90 minus alpha, then this angle will be alpha, and this angle will again be 90 minus alpha. And now you can see that this angle is equal to this angle is equal to this angle, and these two angles are equal, and therefore daughter triangle 1 and 2 are definitely similar. But the mother triangle also has the same angles. You can see 90 alpha, 90 minus alpha, and no wonder then that all the three triangles are similar. Now once you write the consequences of this, you will get all these beautiful formula extremely easily. So let's do that. We are talking about triangle 1, which is ADC, is similar to triangle 2. Now angle A corresponds to angle C in triangle 2, angle D corresponds to angle D, and angle C corresponds to angle B. So I got the correspondence right, and this itself is similar to the mother triangle. So angle A in the left hand side triangle corresponds to angle A itself in the mother triangle. Angle B, angle D here, angle D here of triangle 1 corresponds to angle C, and therefore the last point here is going to be B. So I've got the daughter triangle 1 and the daughter triangle 2 and the mother triangle, and they're all similar to each other, and I've got the correspondences right. So now it's just a matter of writing down the consequences of similar triangles, which I shall now do, and maybe you can also do the same thing along with me. AD divided by CD is equal to DC divided by DB is equal to AC divided by CD. So now let me just substitute. What is AD? AD is D, CD is H, DC is also H, DB is E. And you can see that I got my first formula. Very nice formula. H square is equal to DE. Let's continue. This is equal to AC. AC, where is AC? AC is by CB. CB is E. So now this is also an interesting result, but we are looking for this result now. So let me get to the other triangle. So here anyway, please note that I only got h square is equal to d here. Now let me do this in exactly the similar way. CD divided by AC is equal to DB divided by CB is equal to CB divided by AB. Now let me substitute. CD is H divided by AC is B is equal to DB is E divided by CB is A. This is equal to CB again, that is A, and AB is C. And here you go. You got your second formula, which is A square is equal to EC. So A square is equal to CE is coming from these set of formulae. Now I'm not going to do the last step. The last step is that this triangle is similar to this triangle, and trust me, you will get the last formula, which is B square is equal to DC. And with that, we have got all the three interesting formulae and of course the Pythagoras theorem. So this was the first example of the magic of similar triangles. Now I shall proceed to solve one or two more standard problems, but I urge you to solve the problem by pausing the video, because these are not very difficult problems, but do pause the video, solve the problem. I'm going to solve it, but I'm assuming that you're going to pause the video and make a good, sincere attempt. These are very straightforward problems, but extremely good introductory problems. So let me start. The first, I'm going to state the problem and then urge you to try it. So here goes. The first problem goes like this. It says that you have a acute angle triangle. You have an acute angle triangle, and let's name it A, B, C. Then it says that draw an altitude B, B dash, and also draw an altitude A, A dash. So now what is to be proved? Don't forget that altitude is 90. Now he wants you to prove this. While this is a very straightforward problem, this is a perfect introductory problem. It's kind of situation that will occur quite often. Now you're supposed to prove that A dash C multiplied by BC is equal to AC multiplied by B dash C. Please take 2 minutes off and solve the problem on your own. And I'm going to now solve it, because it's a very typical scenario. What you got to notice is that this is a common angle between these two triangles. This is triangle number 1 and this is triangle number 2. So maybe I'll draw it with the yellow this time. This is triangle number 1 and this is triangle number 2. Now these two triangles have one angle common. Now this is the way to spot similar triangles. One angle common and then just one more angle equal, and you spot two similar triangles immediately. Now these two triangles that I've drawn are similar, and that is the end of the problem. Similar because by AA, and one angle is common and the other angle is 90, and therefore two angles are equal. So let's write down now very carefully what are the two similar triangles and what is the corresponding, write it really carefully, corresponding. So I'm talking about A dash C is similar to Now, angle A dash is similar to angle B dash. Angle C is the same as angle C, and A dash C is similar to B dash C. So these two triangles are similar. I've got the order right, and now it's simple. A dash C divided by A dash C divided by B dash C is equal to AC divided by BC, and I think this is what you're supposed to prove. Basically, this is the same thing as this, and we are done. So this is the end of one nice introductory problem. Now let me do one more last introductory problem for today, and like I said, maybe in the future I shall definitely try to pick up some classic difficult similar triangle problems. They're all easily available. We'll get there. But for today, let's just end with another straightforward problem. But once again, I urge you to please pause the video and attempt the answer on your own. You'll probably get it very easily. So let me state the problem. The last problem for today, it goes like this. There is one arbitrary acute angle triangle. Let's call it ABC. Then he says that there is a square inscribed in this triangle. There is a square inscribed in this triangle. So let's call this as X, 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 and of course 90, 90, 90. Now the height from here is given as HA, and the side opposite A, which is angle A, which we call A is given, HA is given, and you are supposed to find out the value of X. Alright, please pause the video, go ahead and try it for some time. I shall now solve the problem. So here, what you're going to notice is that this triangle is similar to the big triangle. So let's call this triangle something ADE. So ADE is similar to ABC, and what's the reason? The reason is that this line and this line are parallel to each other, because this is 90 and this is 90, and the sum of the supplementary angles are 180, and therefore these two lines are parallel. Now if these two lines are parallel, then this angle is equal to this angle, this angle is equal to this angle, and by AA, triangle ADE is similar to triangle ABC. And I think that's about it. So this length, I told you the corresponding heights should have the same ratio. So this length is actually equal to HA minus X, HA minus X divided by HA, which is the height of the bigger triangle, is the same as this base. Now this base happens to be X divided by this base which happens to be A, and I think we just solve this problem and solve this equation and get the value of X. So let me just finish it. HAX is equal to AHA minus AX, and therefore X into HA plus A is equal to AHA, and this implies that X is equal to AHA divided by A plus HA, and that is the end of the problem. So I hope you enjoyed the nice simple introductory problems on similar triangles, and I shall do another nice topic in the next class. It's called the method of areas, and we'll combine both of these simple ideas that we learned and solve some interesting problems. Till then, goodbye and good luck. I hope you really enjoyed solving these problems on your own. Bye.